Welcome students to Unit 2, the atomic model of matter for chemistry. Today we will talk about the properties of matter, which is a bit of a review. So remember, when we talk about matter, we can describe both its chemical and physical properties. Physical properties can be described as being extensive or intensive, depending upon if that value changes with the amount you have or is independent of how much you have. So if it is independent of how much of the substance you have is known as an intensive physical property. So the temperature at which something boils, overcomes all of its attractions, turns into a gas, or the temperature at which it freezes, where its liquid components have enough attraction to form a solid, those would be intensive physical properties because both a cup of water and a gallon of water would have the same value. Or the density would be an intensive physical property because a cup and a gallon would have the same numerical value. Extensive physical properties change with the amount you have. A cup and a gallon would be different masses or take up different amounts of space. And with that being said, you can answer your first note quiz question. Which of these is an intensive physical property? Pause the video and answer this question in the back of your packet. Physical properties can be measured without changing the substance. You can observe them typically from a distance and say this has a mass of some number, this boils at this temperature. Physical properties can be measured without changing the substance. Chemical properties change the substance by altering how the atoms arrange. Now, all atoms that behave the same are known as elements, and it's the simplest form of matter. For the purpose of this course, we will say you cannot break elements down further, so their simplest form of matter that retains its properties is known as elements. And there are only 92 that occur on this planet. We know of 118 now, but after 92 they become theoretical. Elements come together to form molecules or compounds. So molecules are when you have two or more atoms that have come together. Here we have oxygen atoms that have formed molecules. They are still considered elemental oxygen because the only atom present is oxygen. Compounds are when you have two or more elements present. You can tell how many elements you have if you count the number of capital letters in the formula. H2O has 2 capital letters, so 2 elements. Or calcium carbonate has 3 capital letters, so there are 3 elements in the compound calcium carbonate. Oxygen is just one example of an element that is diatomic. Oxygen is extremely reactive. It pulls electrons from things very readily. So if oxygen is ever by itself, oxygen always forms a compound, like in water, oxygen is with 2 hydrogen, or in carbon dioxide, 2 oxygens are with a carbon. Oxygen, if it's ever alone, will partner with itself, making molecules of oxygen like you see in this picture. There are 7 elements on the periodic table that can never be alone. These are known as diatomic elements, diatomic molecules. You can remember them by the phrase Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine can never be alone. If they are ever alone, they will partner with themselves. Therefore, anytime we say oxygen in this class, we mean oxygen molecules, O2. If I ever say fluorine, I mean fluorine gas molecules. Another way to remember the diatomic molecules is that it's all of the gens. So hydrogen, nitrogen, oxygen, and then remember that column 17 are the halogens. So all of column 17 would give you the diatomic molecules. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine would all be your diatomic molecules. The third and final way that most people tend to remember which elements are diatomic is to remember the TV show Seventh Heaven. If you draw a 7 from nitrogen and include hydrogen for heaven, boom, there are your diatomic atoms. You must remember which atoms are diatomic. This will become increasingly important as we move through the year. If all of the matter present in a sample is the exact same compound or molecule or element, then it's known as a pure substance. So here is an example of sugar. Every single molecule in that picture is 12 carbons, 22 hydrogens, and 11 oxygens. You'll notice that when I described those, I discussed the number of atoms present based on their subscripts. The little numbers that come after each element tell you how many of that atom is present in the molecule. And if you were to count these little dots, you would see that there are 22 hydrogens, 11 oxygens, and 12 carbons. Some compounds, molecular compounds, show their formulas as the exact number of each atom present, while other compounds simply show the simplest ratio of one atom to another. We will discuss the difference between these two in future units. If in a sample you have more than one pure substance, it's known as a mixture. Mixtures can be described as homogeneous or heterogeneous. Homogeneous mixtures means that the particles are equally distributed. So for example, air. When you walk down the halls of Menchville High School, you don't hit a pocket of carbon dioxide and fall down dead. The first breath you take and the last breath you take have equal parts of carbon dioxide, because that is a homogeneous mixture. Or milk. When you pour milk out of a jug, the first glass and the last glass are the same. There's an equal distribution of the proteins within milk, so it's a homogeneous mixture. A heterogeneous mixture is where there's clear definitions of changes in concentration. So for example, when you have a vinaigrette, oil and water, there's a clear separation between the oil and the water. Or if you dig in the soil around here, the first layer is your O layer, where you contains all the organic matter of things that have died, and below that is clay, because we live in an area with terrible soil. You're now able to answer your second no quiz question. Pause the video and answer this question in the back of your packet. You're also able to do page 12 in your packet, classify each compound as an element, a compound, a homogeneous mixture, or a heterogeneous mixture. Pause the video and do page 12. Physical properties can be described without changing the substance, while chemical properties require you to change it in some way. So for example, the physical property of state. You start with liquid water, you end with solid water or ice. What you start with and what you end with is the same. They are both water. However, water has a property that it reacts with platinum to produce hydrogen peroxide. You start with life-sustaining water, you end with vomit-inducing hydrogen peroxide. These are very different compounds. You've rearranged the atoms in that molecule to make something new. The fact that water reacts with something to do that means this is a chemical property. Chemical properties are easy to identify in a multiple choice question. You're looking for the word with in the answer. If they say which of these are the chemical properties, look for the word with, or you look for the word reacts. There are some ways we could hide this, so look for words that mean chemical changes, like oxidation. Oxidation is where something loses electrons, its electrons get pulled away. You are most often see oxidation when something rusts. Or combustion. Combustion is when things react with oxygen. These are words that mean a type of chemical reaction that later in this year you will learn all about. At this point though, just knowing them to be words that symbolize chemical changes is enough. Your next 5 note quiz questions are available now for you, so pause the video and answer these next 5 note quiz questions. And do page 13 in your packet. Classify each property as chemical or physical. Pause the video now and do the 5 note quiz questions in page 13. When physical properties change, that is a physical change. It changes the location of molecules. It changes where they are at or changes their state, but they stay the same thing. So if I take pieces of wood and chop them up, I still have wood, so now I have splinters of wood. That is a physical change. I've simply changed the location of those things. Chemical changes cause the atoms to rearrange. So what you start with is different what you end with. If I burn wood, if I combust it, I end up with ashes. I start with wood, I end with ashes. That is a chemical change. There are 5 signs of a chemical change, which we went over in Unit 1. So remember, the first sign of a chemical change is the formation of a gas or odor. If a reaction produces a precipitate from 2 solutions, you have 2 homogeneous solutions that come together to form a solid that clearly makes a heterogeneous solution, that is a sign of a chemical change. Production of light is a sign of a chemical change, and changing temperature, if something heats up or cools down of its own accord, that is a sign of a chemical change. And if something loses its luster or changes in color, that's another sign of a chemical change. You can now answer the last 4 note quiz questions. Pause the video and do the last 4 note quiz questions for this unit. You're also able to do page 14 in the packet. When the video is over, you can complete your note quiz questions and do page 14. And I will see you next time when we talk about the periodic table and the history behind our atomic model.